Welcome, Calculus AB. This is lesson 3.2, product and quotient rules and calculator differentiation. Let's begin. So let's say you wanted to find the derivative of this function, 4x to the fourth plus 1 times 2x to the fourth plus 3. Your current rules you've learned at this point, power rule doesn't work for this. You can't just say, oh, 16x to the fourth times 8x cubed. That's not actually your answer. So that doesn't work. It only works if they're not like factors being multiplied. Yeah, you could FOIL this out if you wanted to and find the answer too, and that'd be totally valid. But we can also use something called the product rule. If you have two functions being multiplied, and you can think of these as like two separate functions, like I'll call this f of x right here, and call this one g of x. They're two functions being multiplied. We have a rule to make this work. So the derivative of an f of x times a g of x is f prime of x times g of x plus f times g prime of x. I hate putting all those x's in there, so sometimes I just say f prime times g plus f times g prime. So that's worth memorizing. And that's the product rule. So let's do that as an example for this case. So if I said my left hand was f and my right hand is g, what you want to do is you want to write out what your f is. So f prime is going to be 16x cubed. My g prime would be 8x cubed. So now I'm going to multiply using this rule. F prime, so I can say my y prime equals 16x cubed times regular g, which is right here, 2x to the fourth plus 3, plus regular f, which is 4x to the fourth plus 1, times g prime, so 8x cubed. And guess what? That's my answer. I don't need it. I'm done. I could simplify it if I wanted to. And in fact, I'm not going to do that for this one. I'm going to do that for the next one. But there's your answer. Now let's say you want to do it for this one. So I have my f will be 5x cubed, and my g will be 2x squared minus 4. So I'm going to say my f prime is going to be, derivative of that is 15x squared, and your g prime is going to be 4x. So following the product rule, my answer is 15x squared times 2x squared minus 4 plus 5x cubed times 4x. Let's say I wanted to simplify things, combine like terms. So I'm going to distribute this 15x squared, and I'm going to get 30x to the fourth minus 60x squared, and multiplying these together, I get plus 20x to the fourth. Combine the powers right here. I'm going to have my y prime. I'm going to put the answer down here. It's going to be 10x to the fourth minus 60x squared. And you're like, cool, there's my answer for y prime. Now, let's pretend I did this in a different way. So instead of doing the primes, I'm actually go back to this original example, and I'm going to distribute 5x cubed at the start, then do derivatives. So if I distributed 5x cubed, I get y equals 10x to the fifth minus 20x cubed. All right? And now let's just derive this. So y prime would be 50x to the fourth minus 20, minus, I'm bad at math here, minus 460x squared. Why didn't I get 50? Oh man, I did a mistake. 30 plus 20 is actually 50. My bad. Hey, look, these answers are the same. So I could have just distributed first, or I could have used product rule. Now, there might be some cases where you can't just distribute, but sometimes there can. You don't have to use product rule. You can just distribute first. Free country. Quotient rule. So what about this thing? If I asked you to derive it, you might say, oh, like L'Hopital's rule that we learned, so 2x over 15x squared. Well, this isn't L'Hopital's rule. You can't just derive the top and bottom. That only works for L'Hopital's rule. That's not actually the derivative of this thing. You're just deriving the top and bottom separately. So this does not work. We actually have to use something called the quotient rule. When you have a function on the top, we can call this our f on the top, and then a function on the bottom, your g. So the derivative works to this, f prime times g minus f times g prime over g of x squared. And I like writing this out differently as f prime of g minus f of g prime over g squared. So this is something else, yes, you have to memorize, just like the product rule. Now, if you see different textbooks, reminder for the product rule, it looked like this. Different textbooks might put these in different orders. This is the way I like teaching it. One thing you know that's in common is the f prime of g and f of g prime are in the same order. Division, or product rule, it's adding. Quotient rule, it's subtracting with a g squared on the bottom. Just got to memorize it. So let's actually solve this problem right here. All right, I am going to derive, so this is my f and g. So that means my f prime would be 2x and my g prime would be 15x squared. So plugging that in, it's f prime, so 2x times regular g, 5x cubed plus 5, minus regular f, x squared plus 5, times g prime is 15x squared, all over 5x cubed plus 5 squared. There's your answer. Sure, I could distribute things if I wanted to, but I don't want to. There's your answer. Let's try this one. So I'm going to use quotient rule to solve it first, and then we're going to solve it in a different way. So that's your f and g. This would make your f prime, the derivative of negative 9, is 0, and g prime would be 10x. So if I'm solving it with quotient rule, I'm going to get my y prime equals 0 times 5x squared, regular g, minus negative 9 times 10x, all over 5x squared squared. Okay, so if I simplify this, that guy goes away. So you'll have positive 90x on the top. 5x squared squared is going to be 25x to the fourth. And if you reduce that a little bit, you can cancel out one of those x's and reduce this thing by 5 and 18. So you get 18 over 5x cubed is my answer, right? I'm going to do this a different way. So you don't have an x on top. I can rewrite this function as y equals negative 9/5 times 1 over x squared. Think of this like a coefficient. And then I'm just going to derive 1 over x squared. Well, the derivative of 1 over x squared is just negative 2 over x cubed. So I have negative 9/5 times negative 2 over x cubed, which is going to be positive 18 over 5x cubed. And oh wow, they're the same thing. Cool. Okay, calculator differentiation. So we're going to bust out a calculator now and talk about how to do some calculator work. So in the AP test, we have to use calculators to do the derivative at a particular point. So that's like saying, you know, if f of x is x squared, what's f prime of 5? Well, what you did in the past is you go f prime of x equals 2x. So f prime of 5 is 2 times 5, which is 10. And great, that's easy if they're like easy numbers like that. But what if it's a weird thing like this example? X cubed plus 3 to the x, find f prime of 2. Or maybe I say f prime of like 2.5. You're like, I can't do that by hand. No, you can't. But we can plug this into a calculator we use to find at a point. And what we use is something called the n-deriv function. So depending on what type of calculator you have and how to find this, we'll go over this kind of stuff in class. But I'm going to show what it looks like on a TI-89. So let's say I want to do this example. First, I'm going to type in that function. And I'm going to clear these. I'm going to type in x cubed plus 3 to the x power as a function. I can even look, let's go look at the graph of that. Why not? This will be fun. Sweet, that's what the graph looks like. And I got to find the derivative at 2, so that's like the slope of the tangent line at 2. So what I'm going to do is I know that I've set my original function to y1. So I'm going to go to home, and we're going to use a calculus function called n-deriv. And it's a different way to get this if you have an 84. So n-deriv, first you plug in your function. So I could actually type in x cubed plus 3 to the x. Or, you know what, I'm just going to do it that way. X cubed plus 3 to the x. And then you go comma x, comma 2. And if you plug all that in, your calculator gets the answer. Why didn't that work? Is it different on a TI-89? So that should have given you the answer, but it didn't want to plug in that 2, and I think because the TI-89 does it differently. I think I know what the T89 does. We do this, x equals 2. I think you have to do it this way. Right? There we go. T89 makes you type it in differently, but it's a basic idea. So it's 21.887, and we'll do more of that in class. That's not something we do so much in the video, and that's it.